So, good morning, everybody. Welcome to this conference. So, it's a pleasure for me to be here and to have you all here, and particularly Martine and Jonathan, that will present the talks. So, my name, for those who doesn't know me, is Jean-Paul Metzger. In a French accent, for Jean-Paul Metzger. In a Brazilian accent, Jean-Paul Metzger. So, I'm from the Bioscience Institute. And I'm coordinating now a FAPESP Sprint project, which is a special call from FAPESP to foster collaboration between two institutions. So this is a collaboration between the University of São Paulo and Queensland University, and we are just organizing a workshop related to how landscape structure is linked with ecosystem service. So we have this whole week workshop, so a lot of discussion. But we thought also that it could be useful to have a more open session. This is the open session. So to talk for a broad audience about those topics, so related to landscape structure, ecosystem service, and offsetting programs. So I will just introduce very briefly the two speakers, beginning by Martine Maron. I will not read Martine, but Martine has a background on zoology and botany. She's an associate professor at the University of Queensland, and maybe she's internationally well known about her research on offsetting, biodiversity offsetting or environmental offsetting. So she published a lot on this topic. So very nice papers, highly cited papers, but not only doing science, but also supporting policy making related to offsetting. So I know that she's working supporting national governments. So great pleasure for me, Martine, to have you here, and I will let you speak now.
Thank you. Thank you so much for that lovely introduction, Jean-Paul, and thanks so much to everybody for hosting us here over the past week. I'm very sad to be leaving this evening. I've had a wonderful time, and it's been really exciting to hear about all the fantastic research that's going on in this group here at the University of São Paulo. I think that there's a lot of relevant work going on in the area of compensation for environmental impacts. And so I think probably a lot of people here will be already quite familiar with some of the concepts I thought I'd talk about today. But for some people, it might be a little new. Can I ask how many people have already heard of the phrase no net loss? Many? Okay, so yeah, okay, so many people, and not just because you just saw it on the slide, right? I'm just going to bring up some notes, mainly because if I don't, then I talk for far too long. And I promise that I would like this to be, a short talk, a bit of a taste of some of the work that our group is doing on this no net loss concept and its implications, and then a bit of time for some discussion. I like to start, especially when I'm talking to a group of people who haven't heard me talk about this work before, by telling you how I got interested in this topic, because it's actually quite a personal story. We have a farm in Western Victoria in southeastern Australia, and on that farm there is some habitat for an endangered species. This is the southeastern red-tailed black cockatoo. It's got a very long name, but it's a type of parrot, only occurs in Australia, and in fact this type only occurs in a very small part of Australia, close to where our farm is. And these birds, there's only about 1,500 birds left in the world, so it's really very endangered. And the reason it's endangered is because of habitat loss. And these are the sorts of trees that bird relies on, so they eat the seeds of these trees. These are bull oak trees, and they're very ancient. They may not look like much. They might look a bit scrappy, but they're probably about 400 or 500 years old, these ones. And these are in our paddock on the farm. Our paddock is, field. Paddock's an Australianism, I suspect. Now, there's not many of these trees left because they occur in the parts of the landscape that have really good soil for agriculture. So, of course, they get cleared. But the ones that are left should be protected under legislation designed to protect threatened species, right? Because without them, we lose the cockatoo. But one day, and this is nearly 20 years ago now, more than 15 years ago, we got a letter in the mail, and it said, it was from the local council, the local municipality, and it said, your neighbour over the fence, he is applying to cut down 150 of these trees, these ancient trees. So it takes a really long time for them to grow to the size that the cockatoos can use them. And I was really shocked because I was studying the cockatoos. That was my research species that I was working on for my honours project. And I thought, okay, they just don't realise that actually these trees are really important. I'll write a submission and I'll explain the importance of the habitat and it'll be fine. They won't let them cut the trees. Anyway, of course they did let them cut down the trees. But what they did was they said, we're going to allow the neighbour to cut all the trees, but we're going to require that there is an offset. We're going to ask the neighbour tell the neighbour they must plant a large number of other trees of a different type in the corner of their paddock, and that will achieve no net loss. This will help save this species, even though these are not a type of tree that the cockatoo actually uses. And even if you were planting the right type of tree, it would take maybe 100 or 200 years before they are useful for the bird. That is how I got interested in this idea of no net loss. Now, 20 years later, no net loss is cropping up in all sorts of different ways. It's a bit of a buzz phrase. You hear it increasingly in different settings. So, you know, things like zero net deforestation, land degradation, neutrality, no net loss of wetlands, no net loss of biodiversity, no net loss of land productive capacity, of water quality. And so there's quite a lot of these net approaches popping up all over the place. And perhaps one of the most common examples is biodiversity offsetting. The idea that you can do an impact in one place, like the farmer with the trees, and you can compensate by doing a beneficial action somewhere else and achieve a no net loss outcome. And this is a map that summarises a great data set just recently pulled together by the Biodiversity Consultancy and the IUCN, showing where offset policies were appearing. So basically everything other than the grey and the red has some form of provision for biodiversity offsetting or no net loss of biodiversity. So you can see that, you know, globally there are a lot of places. So regulatory requirements, at least some of the time in the green. Australia has a lot, and of course Brazil. And provisions in place to enable voluntary offsetting in the blue. One of the significant drivers of these sorts of permitting requirements, I suppose, is through lending standards. So the performance standards of the International Finance Corporation is one way in which companies can be required to achieve a no net loss outcome if they're going to impact on important habitats for threatened species. But the problem is that even though all of these mechanisms use some phrase like no net loss, they don't all mean the same thing when they say no net loss. And so it's really important if you hear a policy is framed around achieving no net loss or improve or maintain or land degradation neutrality, it's like the question is, well, relative to what do you want to achieve that outcome? Because it doesn't actually tell you. You need to know what the reference scenario is. And the reference scenario is very important because it's actually your goal outcome. So you have to say what that reference scenario is, otherwise there's no way of knowing where that policy is going to take you. So if we imagine we've got some form of natural capital. I've just used that phrase because there's such a range of natural phenomena to which these policies apply. So it might be some biodiversity, it might be forest cover, it might be water quality, land degradation, something like that. And over time, you've got some negative trend. It's going down. We don't want that to happen. We want to introduce a policy, our no net loss policy. The question is, if the policy works, let's assume the policy works perfectly, what do we think will happen now after this? What will happen to the trend? I think the natural assumption is that, well, the trend will flatline and we won't have any more loss, right? But that's only one way of envisaging no net loss. That's no net loss compared to a fixed reference scenario of, in this case, of now, at the time you introduce the policy. Or you can have no net loss compared to a fixed reference scenario of more of that particular natural capital or less. You can draw it down to a lower level. You can still call all of these things no net loss if you're creative. Very often, and mostly for biodiversity offset policies, they don't use a fixed reference scenario anyway. They use a different one. They use a dynamic reference scenario. So they say no net loss relative to what would have happened without the impact and the offset. So it might look like this orange line. And the way you get the orange line is by thinking about, okay, well, we know that there's stuff happening here that's driving decline. And some of that is, say, development, cutting the forest deliberately. And there are other things that are happening as well that are also driving decline, that they're not to do with this policy, though. They're outside the policy. So there's a background trend as well. So the idea of this type of no net loss is to match the trajectory of the background rate of decline. So to be able to do this sort of policy, you need to work out what that background rate might look like. And you achieve a change in the rate of decline. And there are even some examples which say, well, we want no net loss compared to if we didn't have this policy, which is basically the same as saying we're just going to have everything exactly the same as it is now, and it doesn't make very much sense at all. Obviously, a really classic example of a fixed reference state is the forest code here in Brazil. And this is an example that I often use because people are familiar with the very clear reference states that are aimed to be achieved. This is an old image, as you'll know, but the idea is that you've got a fixed reference state of an amount of forest cover, say 20%, and that is what you're aiming to achieve. But in the case of the forest code, I don't believe that the language no net loss is really used. Another example, although it's more complex, is the South African offsets approaches that have been developed for Western Cape and KwaZulu-Natal and are being developed for a national policy. So in the case of South Africa, what they've done is they've worked out, they've got a really good bioregionalisation of their different ecosystem types, and also they know how much they've lost of each of them. So it's quite a detailed categorisation of the different ecosystems, and then they divide that into, if there's, less than 36% remaining, they consider that ecosystem critically endangered. Up to, if there's more than 80%, it's considered least threatened. And then these things are used as triggers for the type of offsetting response that they want to achieve. So the ratio of the area lost, so for each hectare that you clear, you have to just protect another area that already exists. And the size of that area for each hectare of loss depends on how depleted the ecosystem is. And these are linked to these fixed reference scenarios. So a 10-to-1 offset means that you end up retaining 91% of what you had left at the start of the policy. So when everything is either cleared or protected as an offset, you know where you're heading. So this is just one example of how you could do a fixed reference scenario. But it's really very rare. This is not usually the way that these no net loss policies are done. So much more often, they are done in this way. So you have a dynamic reference scenario and you have a landscape with some biodiversity in it, and you want to have an impact. And I should say, of course, that if you're familiar with biodiversity offsetting, the idea is that offsetting is a last resort. So first, you are meant to try to avoid impacts on biodiversity and then minimise the size of those impacts. And so the offsetting component is what you do about any residual impact that you are unable to avoid or minimise. So in this scenario, you might say, okay, well, we're just going to protect some other amount of habitat that already exists, but we haven't really done any work to decide how much that should be. Often it varies a lot from case to case, and so on, until we end up in a cycle where we've just had sort of ongoing decline in the total amount of biodiversity that's remaining. Because all of these areas that are in the dark green, they were there before, we're just calling them something else now. We're just calling them protected. The actual amount of biodiversity in the landscape is less and less over time, and we don't really know where it will end because it's not designed to achieve any particular endpoint. So this is only, you might be wondering, well, how can you call that no net loss? And the reason that you can call it no net loss is if you assume that if you hadn't protected those dark green patches, they would otherwise have been lost. And they would have been lost due to some factor that you wouldn't have had to do an offset for, okay? So you can't say, well, I'm putting in a mining pit here and I'm protecting these two areas. And that's good because probably there's a 50% chance, say, one of those areas might have been cleared for another mining pit if I hadn't protected it. You can't do that because if it had been cleared for a mining pit, you would have had to offset that. So it's only if it's has a chance of being lost for some reason that's not captured in the policy. So it gets really complex. So a simple idea like no net loss can mean lots of different things and it can mean them legitimately, but it leads to a lot of confusion. So we did a bit of a review of this idea to see how this concept was being used in policies around the world of different kinds. So we've got here different types of reference scenarios. So this is a fixed reference scenario that's better than where we are now, fixed reference scenario that's similar to where we are now. So this might be what most people think about when they mean no net loss. A fixed reference scenario that's less than where we are now. So like in the case of, for example, parts of Brazil and South Africa. Or a dynamic reference scenario that is just ongoing decline, or even one that is relative to without the policy, which is the worst case scenario that I showed before. Right, so these are the different types of reference scenario. Better than current state, same as current state, worse, excluding impacts targeted by the no net loss policy and linked actions. That was the one I just talked through on the last slide. So what became evident in this review of the literature is that people are talking about no net loss in two different ways. So there's one way you can talk about it as an overarching policy, which says we want no net loss of biodiversity in this country. And then there are impact-specific policies, which are we want no net loss of biodiversity due to this particular type of impact that's happening. So when you make that distinction, you get really quite different outcomes. So we mapped out and we found that most overarching policies, quite sensibly, were using fixed reference scenarios. So the European Union's no net loss initiative appears to be designed in such a way or phrased in such a way that they clearly intend to not have a decline in biodiversity compared to what they have now. Zero net deforestation policy, a global policy sort of spearheaded by WWF and to which a lot of companies have signed up to achieve zero net deforestation in their supply chain. This is phrased along the lines of achieving zero net deforestation, that is that afforestation would balance any remaining deforestation, by 2020. So that's a different type of fixed baseline. It'll be whatever amount of forest is left in 2020 is the amount that it's meant to bottom out at if this policy is achieved. But we don't know how much that is, but it's presumably less than we have now. So that's why that falls down on this row. The no net loss of wetlands policy in the USA appears to be phrased as we actually don't want to have less wetland area in the US. The way it operates is sometimes different. But the impact-specific policies could mean just about anything. So these are all policies that say something like no net loss is their goal, but all of these different trajectories are possible from all these different types. And they're mostly offset policies. So they're mostly about offsetting a specific impact on fish habitat or on important habitats and species. And there's several here I've illustrated from Australia, and there are more that you could categorise, which fall down in this area. So a lot of offset policies are basically, if they work perfectly, achieving the maintenance of some rate of decline with no particular endpoint. So no net loss can sound really good, but it can take you in a direction that is very undesirable. So how are we going to, I guess the problem with this is especially where you might have an overarching goal for your jurisdiction. You might say, we've lost a lot of threatened species, a lot of habitats, and we've got a lot of threatened species. We can't afford to have any less biodiversity than we have now. And that might be an overarching policy goal. And in fact, many countries make such statements that is in fact their overarching goal. But then the way they seek to achieve it in part is by implementing offset policies that are designed to achieve a declining reference scenario, a declining trajectory of change. So if you have policies that are going on where particular impacts on biodiversity have to be compensated at the cost of the one doing the impact, so the developer or the industry, and the net outcome of that action is a decline, but you've got a public goal of having no decline, the deviation between those two trajectories is an increasing cost over time that's being picked up by the public, I suppose, if in fact the overarching goal of real no net loss is to be achieved. So you get policies that are pulling in different directions happening in the same places. So this is a problem. Ooh, that's interesting. All sorts of interesting things are happening with my animation. The key thing to do, I think, and this is something that our SNAP, a working group that we have, that we just had our second meeting, Laura's part of that working group. Laura Saunter in the back there. So we have a group of around about 20 people working on this problem, drawn from different countries around the world, to try to turn no net loss thinking around and turn policy development around so that we are being explicit about what we mean. When we say, we can't just go out with a shiny slogan and say, we're going to achieve no net loss. You have to say no net loss compared to what? Where is it going to get you if you implement this policy? You have to show the scenario of where it's actually going to take you. So we start with the target. Then you work out where you are relative to your target. So you might say that you want 50% forest cover retained. Well, how much have you got now? If you've got 40%, that means you're below the target. And we would suggest that using fixed reference scenarios is much clearer when we're talking about these things. So you need net gain. So the actions you would do at a particular site can only be improvement actions. Just protecting stuff that's already there can't count. So averted loss doesn't count towards achieving your required gain if you're below the place you already want to get to. Arguably, if we're talking about a threatened species, we are already below where we want to get to. Our target can't be for a species to continue to be threatened with extinction, surely. Implicit in the threat categories is that our target is to have species not being threatened. So arguably, simply protecting some remaining habitat for a threatened species in exchange for losing other habitat is not a valid outcome. However, it might be that you're above the target. It might be that there's been very little deforestation in a country. It's at the early stages of rapid development, and perhaps they're in a position to say, well, we are going to have a certain amount of deforestation, but we're going to put a cap on that, or a floor on that, if you like. And you can do that by designing the biodiversity offsetting in the way that South Africa did. So you're talking more about something that we would call managed retention. I don't think the phrase no net loss is going to work, because what you're doing is reducing the amount of habitat over time. Nobody intuitively thinks of that as being a no net loss outcome. So we need to change some terminology. I've got a problem with this animation, so I'll just ignore what's behind there. So we need to change the language. We need to make the language mean what it sounds like it means. And we need to extend compensation requirements to all the losses. So part of the problem is if you're only having offsets for some part of an impact and not others, then your impact-specific offset policy is not going to achieve very much, and you're accumulating losses that you have to counterbalance. A really good example at the moment is Queensland. Queensland is losing well over 300,000 hectares of forest a year at the moment. We have offsets policies, but they have applied so far to about 400 hectares, right? It's a drop in the bucket. It's not going to achieve anything in terms of counterbalancing the impacts of that clearing, because the scope of the policy is so incredibly narrow. So this means that we really have to get more explicit about setting targets. How are we going to decide what our target is? I already talked about the targets that are sort of implicit in threatened species categorisation. But what about for the retention of different types of vegetation cover? So this is some work that Jeremy Simmons, who's a postdoc working with me on the working group I mentioned, has done to actually so for each country, the proportional amount of natural land cover remaining. I haven't named and shamed the countries here, mostly because we need to do some small changes to the analysis. But you can probably guess where different countries perhaps that you're interested in or work in might lie along this axis. So complete natural cover remaining and no natural cover remaining at all. And then along this axis, we've actually got the variance in the depletion or the variance in the loss of different types of biota. So you can start to think about countries that have, so countries up here are countries that have a fair bit of their, like a lot of their original native cover remaining, but some types are really depleted and other types are very abundant. Whereas down here you have countries where everything is similarly depleted and you have sort of everything in the middle. So looking at these axes, we could start to think about setting targets that would link to outcomes like managed drawdown or managed retention, depending on what you want to call it. No net loss, as in keep the same amount, and net gain, as in you need to restore and end up with more than you've got now, based on this axis. But then in terms of how you would go about achieving that, you can think about, and if you have a very high variance in what's depleted, you might be in a situation where you might have managed drawdown for some vegetation types where for each unit of loss you protect somewhere else, but what you protect is the more depleted type. And that's called out-of-kind trading or like-for-not-like trading in offsetting. So this sort of a target-setting exercise could help guide what type of a policy you might use in order to achieve a specific outcome, a particular target. So there's still a lot going on in this space, and I think one of the big questions that I often get from people working on the concept of no net loss and worried about it sounding very misleading, people who are frustrated with the failings of biodiversity offsetting, which is just about everybody once you start to look into it, is this something we should just throw out? This idea is broken, you know, it is causing too many problems, it is making people believe that we can do development that impacts biodiversity and just offset it, and so it's fine. Should we just throw it away? And I suppose my response is clearly the concept has caused some problems. It has caused a lot of problems and it is misleading and it's being done badly in many, many cases. And it's very hard to think of really good examples of good offsets or good compensation that's well designed and achieves its objective. But it's not going away. It's already very established in the policy discourse globally, and in fact it's morphing into new and different policy approaches as we speak. So increasingly there are these ideas of innovative conservation finance, which is a way of saying we're going to use development to fund the conservation that we should be doing. And these are really risky things that if we disengage because we decide, look, it's a bad idea, we shouldn't engage and discuss, I think they're still going to develop, but they'll develop in a really negative way. So I think that with persistence, we can actually improve these policies and the mechanisms that they're implemented through and actually get better outcomes. But the most important thing, I think, is to build the capacity of the broader public to understand what these things really do, to question if they hear a statement like no net loss, or there will be a great environmental outcome because of a compensation that's done. It's really important that people understand that no net loss doesn't mean what it sounds like it means most of the time. Okay, so thank you very much for listening. I hope that was a bit relevant to some of the work happening here. Cheers. Should I take questions now or... yeah, okay. Well, does anyone have any questions?
Good morning, Martine. Thank you for the talk. I was curious about how is the offset matter for Queensland government and the productive sector or the agricultural sector? Is it how do they see it? Just to make a comparison with our situation here, I would like to know.
Yes, so one of the really big issues, I think, in offsetting globally is that in most countries outside of Australia and Brazil, agriculture is not included. So the major driver of land cover change doesn't trigger offset requirements. In Australia, it theoretically does if you're having a significant impact on a threatened species, which a lot of the large-scale land clearing would, but it's not actually happening. So it's not really being, it's not triggering a requirement for offset. So because the vast majority of the impact from the agriculture sector don't trigger the offset requirements, it's not a particularly controversial issue. There are other regulatory changes afoot that are controversial amongst that sector, but offsets is not really one of them. However, in Victoria, where our farm is, the one I described, so that is an area where agriculture, through the state policy in Victoria, is regulated and does require offsets to be provided if they clear habitat on their farm. And there was a backlash, there was pushback against that. So they had a policy that was already, it was quite complicated, but and moderately effective for offsetting in maybe from about 10 years ago. But in the most recent 4 or 5 years, that has been watered down and made much more relaxed. So now there are many more loopholes and farmers are able to do a lot more clearing without requiring any offsets. So it's complicated.
Good morning, thank you. I'm Luis Sanchez from the engineering school. And well, my question starts from the point of decision-making at project level. So first, I'm curious to know about what happened to the black cockatoos. And that's why when you try to apply those policies, you usually go to project-specific decision-making, which can be a process, well, sometimes complicated, conflictual most of the time. And one thing is to have a well-designed policy, a coherent policy and so on. But a different thing could be really implement that policy and get to the decisions which are consistent with the policy goals. I would like to hear from you about the policy implementation in terms of no net loss or whatever, and which should be the drivers or the most important tools in order to make any kind of no net loss policy workable.
Well, that's a lot of questions. And what happened to the cockatoos? They're still hanging on, but we're still having to fight for better management of their habitat and there is still loss of habitat. There's been a lot of changes, policy changes, that affect the protection of their habitat in the 15 or 20 years since that. And it tends to just move with political change. Whether the state government or the federal government are being helpful or not very helpful, it changes. So that's a saga. But the cockatoo still exists, so that's something. The question about policy effectiveness and implementation. So, I mean, I've talked a lot about the technical and conceptual aspects, but the governance and the way that policies actually behave once they're out there is obviously another major way in which outcomes can be undermined. And my colleague Megan Evans, she's a postdoc in my group, is doing a lot of work focused on that side of things. She's done a lot of interviews with people in the government who work with the consultants in the industry to develop the solutions, the offset actions that need to happen. And she's documented a lot of different ways in which the outcomes can be undermined through that process. One of the ways that we've tried to deal with that, this is again focusing partly on the technical, but we developed a tool, and it's a way that you can put the information about what your offset will be into a very simple Excel spreadsheet calculator, and it shows you step by step how they work out what benefit they think that offset will generate. And then you can compare the amount of benefit to the amount of impact and decide whether you've got a no net loss outcome or not. And that is because it's a very transparent and publicly available tool. It's the same one that the government uses, that industry uses to look at their potential projects and their offsets. People have been trained in it. I think that has improved practice quite a lot because it has laid open for anybody to look at how people worked out what they're going to actually do to benefit biodiversity. But the problem is that usually those calculations are kept between the industry and the government, and it's difficult to get a copy of the completed calculations for any given project. And when I have seen them, I've been worried about some of the logical errors in what I thought was already a very, very simple step-by-step process. And so I think we're still a long way to go, even to having people understanding what they're trying to achieve, let alone building systems that are robust to outside interests wanting to, derail a process. I'm sorry, that's a really long-winded answer and it may not even have answered your question, but yes, it's complicated.
Is there any other questions? I do have a question for you, Martine. I really would like to hear more about your opinion about the forest code. I don't know, I think that the forest code has several problems. And one of them is how we define targets. So we have, for example, for the South states, this 20% target, but we have scientific data that show that the target should be 30%. And usually those targets are much more based on political or economic criteria than on biodiversity or scientific criteria. So this is one problem, but if I challenge you to write a manuscript for us, saying your opinion or how you think we can improve the forest code, which will be the main points that you will...
So I often use the forest code, as you see, in these sorts of talks as just a simple example of how you can start with where you want to get to. And I think one of the really positive things about it is that it, on the face of it, is quite transparent. And so if the forest code says you need to retain 20% cover, and the science says, well, no, if you want to actually, you should be trying to aim for 30% cover, then you can have that debate. You can argue about the science. It might not work, and that's a much more general issue than just this instance and this issue. But at least nobody has the excuse of saying, oh, well, we didn't know that we weren't going to achieve enough cover. No, it's a decision, it's an explicit decision, and if it doesn't fall in line with the science, That's a political choice that they've made, and that's where our influence tends to struggle a bit. But most parts of the world don't even have that. It's hard to have an argument if there's actually nobody even saying, oh, this is what we're trying to achieve, because what do you argue? We argue over little transactions that happen along the way, but we don't think about the big picture. So that's why I like the fact that it's a big picture policy. Only thing is that when you ask people what the target is that they think that they want, it might not be what we think they should want. There's obviously a lot of other issues with the way the target's framed, and 20% of what, and whether it's 20% including the permanent protected areas or not including the permanent protected areas, and that obviously makes a vast difference. And learning about that from you and Clarissa and other people since I've been here has been very eye-opening. And so I think that it's got some good things about the way that it is conceptualised, but I think we still need some standardisation. So if we, for example, wanted every country to put on the line how much land cover, how much natural land cover they are going to retain, so that we actually know where we're heading globally. And, you know, this was to influence the post-2020 biodiversity targets under the Convention for Biological Diversity, for example. How would we constrain the way people set those targets so that they are truly comparable? You know, because you can't have things like, oh, well, 20%, but excluding this thing, or 20%, but we're going to include this and that country won't include it. We need actually some standardisation about how people set these targets, I think. Anyway, so that's one thing, and that's what comes to my mind looking at this. The work that you're doing, of course, on things like equivalence and trading and restoration versus averted loss is really important, and I think that'll give some good answers to that question. Hopefully quickly. By the sounds of it, it's needed soon. No pressure.
Thank you, Martine. And so the invitation is done to you. If you want to write an opinion paper, you'll be welcome to do that.
I would be mortified to do it on my own, but I think there are many experts in this room who might join me.
Sure.
Great. Thank you very much.
Thank you a lot.
Cheers.
So we will move to the second speaker, so Jonathan Rhodes. He's also associate professor at the University of Queensland. He has a PhD in ecology and some backgrounds also in economics and mathematics. And I would define Jonathan as a landscape ecology. I don't know if he agree. Yeah. So his main research is on landscape ecology and conservation, and he began to work initially with koala conservation, so with threatened species conservation. And then he moved, such as I did also, to ecosystem service, so to the links between landscape structure and ecosystem service, particularly in urban areas or in cities. And his research has a lot of implication for applied issues like policies. So, Jonathan, welcome, and thank you very much for being here and present this talk.
Okay. Thank you, Jean-Paul, for the introduction. It's wonderful to be here. I arrived a day late, not by any fault of my own, so I got only a short time here, but it's been really wonderful being here and meeting everyone, and it's been a fantastic workshop on so myself and Jean-Paul and Martine's involved as well in this, I guess a few initiatives thinking about landscape structure and ecosystem services, and I think we've sort of, both our research groups have been working on this, but I guess this has brought us together a little bit to collaborate on this, which is really, really exciting. So we have this group, which is a FAPESP Sprint project, and we also have an SDIV working group as well, focusing on similar theme, and a few people here are involved in that as well. So I think it's a really exciting area. But I actually thought, since we've been speaking all week about ecosystem services and landscape structure, I thought I'd talk about something completely different, and nothing to do with landscape ecology, nothing to do with ecosystem services. And this is, guys, another area that I work in. I am a landscape ecologist by training, and I focus on a lot of my interests at the moment lie in thinking about landscape structure, landscape change, and ecosystem services and policy. I've done a lot of work on koalas, and I guess that's where a lot of my landscape ecology has focused on over the years. But I've also been really interested in monitoring, and I think sort of, and I've been involved in developing monitoring programs in the past, and when I was and I've often originally sort of thought about monitoring from a statistical point of view, and I think monitoring for conservation has often been thinking about monitoring has been driven really by thinking it from a statistical point of view. So how much monitoring do we need to get a certain level of or a reduction in uncertainty or precision, or what's the number of sites we need? And that's, I guess, in the past, that sort of dominated the history. And I think if you look at sort of conservation programs and monitoring, that's a sort of philosophy, I guess, people have taken, is taking that more statistical point of view. But when I was a PhD student, I went to a workshop on, this is probably 15 years ago now, and on monitoring and optimal monitoring, and thinking about monitoring in a completely different way, and thinking about monitoring really as a decision that you make. So, and I think we've become used to thinking about making management decisions, but often we don't think about monitoring in the same way, and we often tag monitoring on to the end of a conservation program or some work we're doing, and don't really think carefully about the decisions we make in monitoring. And so I guess since that sort of workshop, I've been interested in thinking about monitoring in that way and thinking it more from a decision point of view. So obviously there's some statistical aspects to that, but really thinking about that in that different way. So what I was going to do today, and I'm happy to, if people want to talk about the landscape structure and ecosystem service stuff we do, I'm happy to talk about that later if you want. But hopefully you'll find the monitoring stuff interesting as well. So I guess sort of over the, I've sort of been working a little bit on this over the last 10 or 15 years or so, and I guess we're really trying to think about how do we develop new frameworks and insights from thinking about monitoring as a decision rather than just something we need to statistically optimize. And so if you look at conservation programs or you look at conservation monitoring, that monitoring tends to be a core part of most conservation programs, but the types of monitoring and the scope of monitoring for these programs varies enormously. So a lot of monitoring programs are just surveillance monitoring. They don't really know what to monitor. We'll just monitor some things and we'll see what happens, and maybe we'll learn something useful. Some monitoring programs are very targeted, so they may focus on asking a particular question, learning about a particular parameter of a population, a mortality rate, for instance. We have this, I guess, dichotomy between long-term and short-term monitoring, and I think people accept that long-term monitoring generally is more valuable, and so we can start to learn more over the long term. But long-term monitoring costs more; it's more difficult to implement, and so I think these short-term monitoring might be cheaper. It might actually give you the answers you want for particular questions. So often these things are not really very well thought about. They vary in terms of what we monitor. So do we monitor ecological components of a system? Do we monitor social components of a system? And most conservation problems involve both ecological and social aspects, and so often that's a key question. And if you look at conservation monitoring, it varies enormously in the components of the system that they monitor. So I guess this brings to mind, well, given the diversity and different approaches to monitoring, and the other thing I should mention is they vary enormously in the investment in monitoring. Some have large proportions of budgets or emphasis on monitoring. Some have very little. Some it's just a token gesture. So again, there's a decision to be made. So essentially, there's these wide range of decisions, lots of choices in different monitoring that we can do. And really, it should be thought of as a decision problem. Okay, so if you want to think about monitoring as a decision, the first thing you need to do is think about why are you monitoring. So if we don't understand why we're monitoring, then we're never going to be able to make a good decision. Okay, and really, I think there are four main reasons to monitor. Okay, so the first one I have there which is what I call accounting. And what I mean by that is that really this is just monitoring to track progress towards some kind of objective. So it could be we've just heard about the sort of no net loss and targets and so on that Martine's talk. So it could be we just want to measure, are we meeting our target? Or are we meeting our no net loss objective? So that's what I sort of think about as accounting. It's just really, did I meet my goal or did I not? The second reason for monitoring, and the one that I have focused on most, is monitoring to improve management decisions. So you might think of a problem where we have, maybe we have two types of management actions. We've got a place where we're trying to protect a threatened species, and we have two choices, things we could do. We could either do some restoration, or perhaps we could fence the area to keep to reduce grazing, for instance. But we may be uncertain about which is likely to give us the best outcome. So we might implement a monitoring program to learn about the effectiveness of those two management actions, and then in an adaptive management cycle, improve that management over time. But that's a very different objective to the first one, which is accounting. So your monitoring is likely to be very different, depending if you have that objective. The third reason for monitoring that I've identified here is engagement. So this is really, it's engagement with the public, and I think we see, if you are familiar with sort of the growth of citizen science, I think there's a real interest in how do you use monitoring to engage with the general public. And I think monitoring itself can be an engagement tool. So it may not be anything to do with tracking progress towards objectives or improving management decisions. It might be just, let's use monitoring to engage with the public. And I suspect underlying many monitoring programs are engagement with the public. It's just how do we engage people in our conservation programs and so on. And that's fine, but it's rarely explicit in thinking about monitoring. And again, your monitoring strategy will be very different for that objective compared to the other two. And then the last one I have there is surveillance. And I'm not sure, I'm not sure whether or not, these are not necessarily all mutually independent. And I think surveillance could probably go across 1, 2, and 3 as well. But really the surveillance monitoring I sort of have as a separate category here. And I see this as, you sort of don't know maybe we know nothing about the system. So we're just going to monitor some stuff and we're going to see if we learn anything. And by serendipity, we might learn something useful in the future. And again, I don't think there's anything wrong with that. And there's been a lot of debates in the literature about having surveillance monitoring versus targeted monitoring and the costs and benefits of each. But we should be explicit about that objective if that's what our monitoring objective is. And so I think often we don't think carefully about the monitoring objective. We need some monitoring, we'll just do some monitoring, but we don't think about the objective very, very well. And I think there's a lot of improvement can be made there in just formulating the problem properly and thinking about why we're monitoring. And I think I've sort of evolved in the years, particularly in advising on monitoring programs, particularly for my work on koalas. And it's the first question I always ask is, why are you doing the monitoring? And often the people designing the monitoring programs say, well, I haven't really thought about that, or they say something vague. And so I try to really ask them to get to think critically about why you're doing the monitoring, and given you're doing that monitoring, why you're choosing that type of monitoring strategy that you are. So I think that's often missing. So critical thinking about objectives. So that's sort of, I guess, I think we should think more about objectives. But I'm going to talk a little bit mainly about our work in thinking about conservation for management. And I guess that's a lot of the focus of my work is around that. How do we design monitoring? And I think I use monitoring here in the broad sense. Monitoring could be monitoring over time, but it could be focused research on learning about a system as well. So if you have a particular question about an ecological process or a social process, how do you design a research program or monitoring to answer that question? So in this sense, I'm thinking about how do we monitor and then improve management over time. So in this case, you've got, in some ways, coupled decisions. You've got a monitoring decision to make, but you've also got a management decision to make, and they're not independent because, in theory, the monitoring should inform the management, and ideally in an adaptive management cycle, although that's rarely done. But anyway, I guess over the years, there's been lots of debate about monitoring, and I mentioned this sort of debate about surveillance versus more targeted monitoring and asking particular questions. So I guess there's literature articles in the literature about thinking more objectively about monitoring and taking a more objective decision-making approach for monitoring. And I guess, so that's sort of, there's some of that in the literature. It's still, it's a handful of papers really that try to do that. And I guess from that, we get a few insights. And I guess the first thing I'd say, and this is perhaps this is a no-brainer, and it's that the first point really is that if you're monitoring for management, the monitoring itself doesn't have any value itself. Okay, so the monitoring does nothing. And I hear it time and time again that, we're going to do some monitoring and that will help the management of our threatened species or whatever. But it doesn't. The monitoring doesn't protect species at all. The monitoring only protects species if it helps us make better decisions in the future. Okay, so there has to be this explicit link between monitoring and the management decision making. So if there isn't, the monitoring has no value. So if there's no link between just monitoring and any improvement in management, there's the value of that monitoring is zero. Okay. So I guess that's the first, perhaps, insight from some of this work and some of our work as well. And perhaps that's obvious, but when you ask people about this, they often haven't thought carefully about that. So I think often we actually monitor quite well. In many cases, what we don't do well is linking the monitoring to actions. So we don't have this I guess, a framework by which that monitoring actually then improves management. I think that's often the problem with monitoring, not what we're monitoring. But the focus has always been on what we're monitoring. I don't think it should be. It should actually, often it should be on how do we make better use of our monitoring data. And that's difficult. I mean, there's obviously often politics and policy and so on wrapped up in that. So it's not easy. And then I guess so let's assume we have some link between monitoring and management, and then think about what might drive the benefits of a particular monitoring action. Okay, so here we're assuming we're going to do some monitoring. We're going to take an action based on what we learn. So in theory, we're going to improve our management. There are cases when that monitoring value might be low still, despite that. Okay, so I'm really interested in trying to identify those places when monitoring is valuable and when it's not valuable. Can we generalize this and ask questions about when monitoring is valuable and when it's not? And I think some insights from other people's work and our work is that when monitoring costs are high, the value of that monitoring might be low or close to zero. And this might be specifically the case where doing more monitoring actually takes away from your ability to do more management. So you're sort of dividing up a pie, and if you do more monitoring, you're going to do less management. Okay. So if your monitoring costs are high, the value of that monitoring is not particularly high. You're likely to have the benefits of that monitoring in terms of improved management may be low as well. And it varies from case to case. Sometimes the funding for monitoring comes from a different source to management, then it's a different situation. But that's certainly one case where the value of monitoring may be low. So your monitoring may reduce uncertainty a lot, but actually not result in any improvement because of the cost of that monitoring. The second case I've got there where monitoring, the benefits of monitoring may be low, is when it doesn't change a management decision. So this might be the case where we have a monitoring. So let's go back to the example I used a minute ago, where we have a threatened species we're trying to manage, and we're trying to decide whether we do fence or do restoration. And we may find that actually, given the current information, it's blindingly obvious what the best management decision is, given current information. So if the decision to do restoration, for instance, is blindingly obviously the best management strategy, doesn't matter, given uncertainty, given the information we know, monitoring's not going to change that on a priori. It's not going to change that. Okay? You could get a surprise and you could just be wrong, right? That's possible. But a priori, given everything else, probably monitoring is going to be a low value. Okay? So in that case, monitoring might not help, even if we're highly uncertain about the actual benefits of those two actions. But we might be very confident about the relative benefit of those two actions. And then the third case is where the management decision doesn't matter. So this might be the case where fencing and restoration are equally beneficial. Doesn't matter which one we do. Okay? So a priori, given current information, we may decide these are equally good. Doesn't really matter which ones we do. Maybe we'll just do both, or doesn't matter. In that case, it doesn't matter either. Because if we monitor and learn about one of the benefits of each of those ones, on average, we're probably going to find out they're fairly similar. Okay, but again, by chance there could be a surprise, and we just might be wrong. We might be wrong. They might not be similar. So this is I guess economists have looked at this a little bit like a colleague of mine from the University of Western Australia, David Pannell, refers to this as flat earth economics, ways of saying that your payoff function of different management actions is very flat. So it doesn't matter. The payoff, regardless of what you do, is the same. And in conservation problems, that might be the case sometimes as well. So in those cases, your monitoring might not be useful either. So it might not be very valuable. And so I guess the key point I'm trying to make here is that if we start to think about, first of all, the decision is should we monitor or not, sometimes the answer might be we shouldn't. It's going to give us no additional information or nothing useful to improve management. So, and I think it's equally valid to think about it in a structured way and say, actually, we know enough. We know enough to make a decision. Let's spend on monitoring resources on management. That's going to give us our biggest benefit. So I guess those are some of the insights, and I think that's what the first question is really, should we monitor or not? And then the second question in my mind is well, I'll go back to that question about whether there's this link between monitoring and management, and so if you're going to have any improvement in management, then there's got to be this link between monitoring and management. And myself and my PhD student, Payal Bal, recently did this review of the literature looking at this. In this case, we looked at a subset of the monitoring literature, and we looked at species indicators. And we did a review, and we reviewed about 100 to 150 papers, and chose evaluations of species indicators that in those papers claimed that the indicator itself, the purpose of the indicator was for management. So a priori, they're saying this indicator is for improving management, okay? And then we looked at those papers and then looked at the way they evaluated those indicators and asked, to what extent did they consider management, and to what extent did they consider monitoring? And in this graph here, this is just one of the, this is currently in revision, so it's not published yet, but we looked at, so these are what we deemed to be the components of a decision problem: defining objectives, your constraints to your decision problem, what actions you're going to do, the uncertainty in your outcomes, predictions, and some quantitative measure of outcomes under different decisions. And we looked at two different aspects of those decision problems. One is just the monitoring decision. So in that case, so this was a monitoring, so looked at what are the monitoring focused decisions. So this might be things like your actions being your different monitoring actions, your uncertainty being uncertainty in your estimates of parameters or trends, objectives being often, in this case, sort of minimizing the difference between reality and your predictions. So those are very focused on monitoring. And then we also looked at the management-related components of the decision problem and asked the same thing. Did they consider the ultimate management objectives, the constraints to those management objectives, those management component, the actions, the uncertainty, and the outcomes? And so what we found was that in this case, so the green areas here are the dark green areas where they explicitly evaluated that component of the decision problem in their evaluation. And for monitoring, in most cases they did reasonably well. So obviously, in most cases, consider the action. Well, by definition, you have to, if you're evaluating an indicator, your action is whether to use the indicator or not. They often considered objectives. Constraints and uncertainty were less often considered, and the outcomes were often considered. So did pretty well, really. So, in terms of formulating that, in terms of monitoring outcomes. But when we looked at the management aspects, they did much more poorly. So a few papers actually, this dark blue is where they explicitly considered the ultimate management actions that this indicator is supposed to inform and evaluated the indicator in that respect. But hardly any of them even discussed the management. What was this indicator supposed to inform? And despite the fact saying this is useful for management, that was never explicit. And if you're going to evaluate an indicator for management, you've got to say something about what the management outcome might be. So despite some literature sort of around, I guess, making this point of thinking about monitoring as a decision problem, at least in the literature, there's very little evidence that this is really being taken seriously. And I suspect, and we haven't really looked at the grey literature and sort of conservation plans, but I suspect you find similar aspects of linking monitoring to management explicitly. So what I'm going to do, I'm just going to go through, I'm going to give you just 3 examples of some work that we've been doing in trying to think about the monitoring as a decision problem and some of the insights you get from doing that and how those insights are, well, firstly, some of the methods that we can use to do that more explicitly, and some of the insights you get on how the decisions you might make in terms of monitoring are different once you think about monitoring as a formal decision problem. Okay, so the first example is one that we worked on a few years ago with a research fellow at UQ, Howard Wilson, and Hugh Possingham, and we were interested in thinking about monitoring threatened species. Okay, and we were there's a number of examples around the world of using project prioritization approaches to manage threatened species, where you essentially take a cost-effectiveness type of approach, and then you estimate the benefits for managing a particular species in a particular way, and the cost of managing that species, and then you essentially rank them in order of cost efficiency. So you divide the benefit by the cost for each species, and you basically rank them, and then you sort of say, right, well, I've got so much this, I've got this much funding, I'll pick the top so many, and those are the ones I'll fund. That's my most efficient way of investing in threatened species management. So examples are, there's a good example in New Zealand doing that. In Australia, New South Wales state government have done something similar. And there's probably a few other examples around the world. But the question is, we're often uncertain about the benefits we might get from managing a species. So we might want to say, well, over time, if we may want to monitor these species, re-estimate what the benefits are, and then re-rank all our species again, and then do the prioritization again as a sort of adaptive management loop. So we were interested in coming up with some general principles. If we framed our monitoring problem in terms of the benefits we might get in terms of threatened species management, what types of rules might we come up with to inform which species we might monitor? So we sort of simplified things a little bit and assumed that species are either declining or not declining, okay? And we could monitor, but we're uncertain. We're not exactly sure which ones are declining and which ones aren't, because some of them we might not have monitored. We don't know. Maybe some people have a guess. Some species we've monitored, but it's not very good monitoring, and we're uncertain. And But we could potentially monitor to get a better estimate of whether the species is declining or not. We might decide not, some species we might not to monitor. So the monitoring question is, which species should we monitor, okay, to maximize our future benefit in terms of threatened species management? So what we did was we assumed we rank species based on this DI divided by CI. I is just a species, and this D is just the probability that the species is declining, okay? So if we're more confident the species is declining and we manage it, and we assume that if we manage it, we stop that decline, then the benefit is just the probability that it's declining. That's what we get. So that's the benefit. And then we divide by the cost. So this is just the cost of doing that management. So we have a bunch of species, got some probability they're declining, some cost, and the benefit is just the probability of declining divided by the cost. And if we were to ignore the decision problem, and we said, well, which species should we monitor? We would just say, monitor the species where this D is closest to 0.5. So 0.5 is where we just don't know. It could be declining, could not be. We don't know. That's the most uncertain state. And so we would say, we'll just monitor the ones that are most uncertain, because that's the ones we're going to get the biggest benefit from monitoring. So that's sort of your traditional, statistical, monitoring-focused approach. Okay? So we approach it slightly differently. And so we assumed we ranked the species this way. So we've got the most cost-effective species at the top, the most cost-ineffective species, maybe inefficient, maybe? I don't know, maybe that's the wrong word. Anyway, so from top to bottom, and then we assume we make a decision. We've got a budget limit. We've got, $100 million, and we're going to work our way down the list, and we're going to fund the ones above that and not fund the ones below. So it's a bit like, running a grant and getting funded or not, okay? The species either gets funded or it doesn't. And so what we showed, actually, is that, and maybe this is fairly intuitive, but we're able to show it analytically as well, is that, I should mention this. So the ones above the budget are the ones we take action to recover the species. So these are the ones we assume, in this simple example, we assume we recover the species. And the ones below, we take no action to recover the species, okay? And we're trying to maximize, essentially, the number of species that persist. Okay. And what we find is that, can you see that? Oh, maybe you can. Okay, so what you find is actually, and maybe this is fairly intuitive, is that the things to learn about or monitor are the ones closest to the boundary. So they're not the ones that are most uncertain, they're the ones closest to the boundary. The uncertainty comes in a minute. And that's because the ones just above the boundary are the best ones to learn to know that are not declining. Because if they're not declining, we know with certainty they're not declining, then we wouldn't invest in them. Okay? And we would monitor those because they're the most expensive ones that are just above the boundary, and the most expensive ones we could be making an error in funding for recovery when it's not necessary. Or the ones just below the boundary are the best species to know that are declining, because they're the cheapest ones that we're currently not funding, that if we knew were declining, we would fund, okay? So we came up with a simple rule, and maybe it's pretty intuitive, but the point is that if you think about the decision, the monitoring action is completely different to if you don't think about the decision. The uncertainty stuff does come in, because if we've got equally beneficial species we could monitor at the boundary, then you monitor the one that's most uncertain, okay? So, but it's not, the decision is not driven purely by uncertainty. So that's one example of a case where in that case, we're assuming we're going to monitor, but we're trying to choose which species to monitor, and we come up with some simple rules. The second example I'm going to show you is really a question around whether we should monitor or not. And this is related to some of my work on koalas. I've been working in a population over here, just south east of Brisbane, which is sort of one of the most highest density populations in Queensland. This is the distribution of koalas, and they're currently listed as vulnerable. And so So we're interested in this population, and we've actually got quite a lot of information about this population. There's been a long-term monitoring program in this area, but there's been an 80% decline. This is the decline over time. In the last 15 to 20 years, an 80% decline in this population. So the population's crashing, so it's in serious trouble. Okay. Yeah, you can see it on, I can't see it on there very well, but here you can. So, and one of the problems is high mortality. So these graphs, don't worry about the axes here, but these are just different age classes. And we've got data on different age classes and the mortality rate associated with each age class. And for each age class, we know the cause of mortality. So I've got a model of the effect of different causes of mortality. Threats are really, for mortality, are dog attacks, disease, and vehicle collisions. So it's an area that's highly urbanizing, a lot of land use change, and it brings with these other threats. And so we've got pretty good information, right? And but one of the questions is, what should we manage? And should we manage mortality, different sources of mortality? So should we do something about dog control, or do something about vehicle collision, or should we be putting habitat back? So we're losing habitat as well. So should we be restoring habitat? So you can see the error bars on there. So there's a reasonable amount of uncertainty in some of these. There's also a reasonable amount of uncertainty or quite a lot of uncertainty in the effect of habitat on population persistence and population growth rate. So we're quite uncertain about that. And that's probably where the biggest uncertainty lies. So our ability to predict the effect of habitat restoration relative to doing things for mortality is quite there's a lot of uncertainty. We can't do that very well, even despite lots of data. Okay, so really the question is, if we were to do some monitoring or some learning to reduce that uncertainty, what would we do? What would we invest in, or would we invest at all? So the question we try to ask actually is the question: which should we learn more about this population? But should we learn more about this uncertainty about the effects of habitat on the persistence or growth rates of the population? Okay. So, and we did some work with a student of mine, Sean Maxwell, and where we took an approach called value of information analysis. And so this is an approach that I use quite a bit, and it's really an approach to explicitly value the improvement in outcomes of decisions made with new information. And essentially, there's an equation at the bottom, don't worry about that. If people are interested, I can explain that. But basically, what it does, it says, let's estimate the outcomes of an optimal management decision made with new information we could collect. So that gives you some outcome, okay? In the case of this example, we used population growth rate as our outcome. We're trying to maximize population growth rate because it's strongly negative at the moment, and we want it to get closer to zero. And then you take away from that the outcomes of an optimal decision. So it assumes we use the information optimally. So it's a perfect transfer of information to the decision problem. The outcomes of making an optimal decision without new information. So in this case, we're choosing whether to invest in habitat restoration or direct mortality management. And just to show, there's some maths underlying this. This is the equation. I'm not going to explain it now, but if people are interested in value of information, you can do it in spreadsheets. You can make it complex, but it's possible to do this in a spreadsheet. And so it's simple, right? So you just say, what am I going to get with new information? What am I going to get if I don't have that information? And the difference is the benefit you get from that from that monitoring. Okay. And so this is some results from that paper which we worked on with Sean, and so this was a couple of years ago now. And so we calculated a thing called the expected value of perfect information. So this really gives you your upper limit of the amount of information you can get from learning. So this assumes that we eliminate uncertainty about the link between habitat and the impact on population growth rate entirely. So it's unrealistic, but it gives you an upper limit to what you could possibly learn. And so this shows one of the key results is that, so this is your expected value of perfect information in terms of your improvement in your growth rate. And this is the the management budget. Okay, so we assumed we could spend different amounts of management budget on either managing habitat or mortality. Okay, and this red line shows you the expected value of perfect information. So it doesn't quite go to zero here, the budget. So for small budgets, the expected value of perfect information is highest. Okay, because at small budgets you've got lots of degrees of freedom in what you could invest in. As you increase the budget, expected value of perfect information goes down because you eventually exhaust all the possible management actions you could do, so you don't have much leeway in terms of different types of management actions you could do. So it approaches zero. But what you see here, this number is tiny, right? So it's 0.0003. Okay? So what it's saying is, that's tiny. So the population's declining at 8% a year, and by monitoring, you could improve it by 0.003. Nothing. So the monitoring actually has no value. And actually, as you invest in more and more, the monitoring becomes less and less valuable, okay? Despite high uncertainty. And I'm going to explain why that's the case in a minute. In this case, we were also able to turn that into a dollar value. So along this axis here is the what we call the financial value of information. This is in Australian dollars, and that actually increases as your management budget increases, partly because it's just a proportion of a higher management budget. And it goes up to roughly about 1 million. But up here, this is 1 million out of a $200 million budget. So again, it's tiny. The actual benefit you get is small. And the reason for that is that the habitat restoration component is so much more expensive than doing the direct mortality control that it's blindingly obvious what you should do. You should manage mortality directly. So despite lots of uncertainty, in knowing the effect on habitat restoration, on growth rates, because of the economic side of it, if we're trying to do something that's cost efficient, that dominates and you get virtually no value of learning. So probably in this case, if you've got a lot of uncertainty about the cost, that's probably what you should learn about, but we haven't done that analysis. So that's an example where, despite lots of uncertainty, the value of information, of learning, is low. And remember, that's the maximum we could get from learning, from monitoring. Okay, so the last example I was going to give you is some recent work that I'm doing at the moment. And again, this is not published, but it's getting close. And this is some work we're doing and thinking about, should we learn or monitor social or ecological systems? And something that I'm interested in, I think there's been a lot of emphasis on investing in research in social systems in conservation, which I agree with. But there must be cases where, if that results in a reduction in focusing on ecological aspects, that if there's this trade-off, there must be a limit to that. So I'm interested in what cases should you invest more in social aspects versus ecological aspects. But in this example, we just looked at these social aspects, and we were interested in thinking about different social network structures where we have a network and we have managers at the nodes of our network, and they manage particular species, or they have species on their land. And as a conservation organization, we can go and influence those people to protect their species. But these landholders are not acting independently. They talk to each other and they collaborate and they share information. And so you can, if you're a conservation organization trying to engage with landholders, if you know the network, you could use that strategically to get better outcomes across a landscape. And so perhaps there's a bit of landscape ecology in here, but just a little bit. These are not real landscapes. And then, so we designed this as a decision problem and said, well, what given our management action is, we want to know who to engage with, and what's the value of learning about the network? So what's the value of learning about these social connections? And how does that vary with network structure? And this is just a snapshot of some of the results. These are so we looked at small networks around simulations. And basically, to cut a long story short, these more centralized networks had the highest value of learning about the network. And that's largely because you can use that centralization, that central actor, more strategically to influence the decisions of other actors. But the really interesting thing that we found was that when you think about the distribution of species across nodes, then the value of information also depends really strongly on the nestedness of species across those sites. So when we've got highly nested species, highly nested species, the most species-rich site, all sites are pretty much a subset of the most species-rich site. In that case, the social network virtually has no value in learning about at all. And that's largely because it's the optimal decision is driven almost entirely by the ecological component. And we've run this on some real data from an artisan fishery in East Africa as well, and find similar results. So there's some interesting interactions here between the social component and the ecological component in driving the value of learning about the system. Okay. So that's, I guess, an example where we're thinking about how does the system drive the value of information, but in a decision context as well. Okay, so that's sort of a bit of a snapshot of 3 examples of some of the work we're doing, and I guess three sort of take-home messages is really that monitoring decisions must consider management to be effective. So we need to consider that management, and we need to consider it in terms of the way in which we design our monitoring strategies. We have a bunch of tools that have been developed that allow this to be done, and some of it can be done in spreadsheets quite simply, so I think it's becoming more accessible to people. And I guess linking to that first one, once we consider management, our monitoring decisions are very different from when we don't consider management. So I guess emphasizes the importance of thinking carefully about the objective. If your objective of monitoring is not management, again, you would have a different monitoring strategy. Okay, so I'm going to leave it there. So I guess just acknowledgements so some of this was funded by the ARC Centre of Excellence for Environmental Decisions and the Swedish Research Council and the Queensland Government, and just I think I mentioned most of my sort of co-authors, I think Payal, Hugh, Howard, Sean, and then on the network stuff I've been working with Eugene, Didine Chades, Oyan Bowden, Angela Guerrero, and most of the people involved. Thank you.
Thank you, Jonathan. Questions?
Thank you. I'd like congratulate you for this great talk. I'd like to make a comment. I think there is a huge amount of money invested on biodiversity monitoring in Brazil. But in my opinion, we are monitoring for nothing. And I see some reasons, some things that explain this is the first one is that we don't have a clear question. We don't know why we are monitoring and for what we are monitoring. The second is that we don't know what to do with the huge amount of the data we are collecting. We are just collecting. And I include myself in this. And the third, I think maybe the most important that explains the first two, is that we are not linked with the decision makers. So there is an enormous gap between us, researchers and decision makers. And this is why I believe that we need to bridge this gap. And this is why I think you can be very helpful for us, helping us in to find practical ways to bridge this gap and to monitor for something and to influence decisions in conservation. So this is, I liked very much your talk, and so thank you.
Yeah, I just might comment. I agree with the linking with decision makers. To me, that's the most critical barrier, is talking with decision makers and getting them to think critically about their monitoring and why and what the benefits are going to be, and just thinking through that process, I think if we could do that, I think our benefits from monitoring would be massively improved. Often there's not a lot wrong with the monitoring that we do itself, but it's linking it to decisions is the real missing link, I think. Yeah.
Hi, Jonathan. Thank you for the nice talk. There is another aspect which I think does not improve so much the monitoring aspect, because I don't know, but here in Brazil at least, I have the guess that monitoring is considering such a minor science, you see? So this, I think, is very bad because people are not stimulated to research on monitoring. What do you think about this?
So you think your comment is really that people are not really motivated, because it's not research. And that's a problem. I think monitoring's boring, right? It's just, but so I'm not. I sort of make the distinction between research and monitoring, and I'm not so sure monitoring is a research activity. It should be funded by governments and conservation organisations that monitoring for monitoring. And I don't think this expectation that universities should do the monitoring, for instance, is necessarily the right approach. I mean, because it's not research, and we're often motivated by different things, and so I guess so I think maybe there needs to be a different way of thinking about monitoring as a management action. And I think if you think of it's not the case that we think about that way for management actions, but if you think about monitoring as a decision that actually improves management, it may change that sort of way of thinking. And I guess your first comment, I think, was about the low levels of monitoring, I guess. And was that right? Sort of in terms of investment in monitoring? And I think if that's the case, that's fine, but there should be a reason for it. So I showed you some examples where monitoring, the best decision is not to monitor. But if you're not monitoring, then it should be a carefully thought out decision that we think we're better investing in management, for instance, rather than monitoring. And that's fine, but I think it should be thought through carefully in a structured way and make sure that that's actually the right thing, rather than being the default that, monitoring's boring and no one's interested and it has no effect anyway. Part of the problem is making monitoring more effective.
Hi, Jonathan. Hi. Thank you for the talk. What I'm going to ask is, it has to do a little bit with Vanya's question, I think. Well, not directly, but I was going to ask if it's not part of the concept of monitoring that you have some sort of a value of reference, because you see what goes on in some time, and then you compare to what? Because I think maybe that's the boring part of it. You just see what's going on, and maybe in consultancy in which I had experience with, we usually do that. You just see what goes on. You don't really compare to what happened before. Yeah. You don't have a value of reference. You're just diagnosing over and over again. Yeah. Maybe that's the thing that makes it less interesting. I don't know.
Yeah, maybe. And in some ways that information is worthless. I mean, for what? Why are you doing that? And I think, I suspect if you started thinking more clearly, first of all, why you're monitoring. Do you want to monitor relative to a reference? Then you've got to start thinking about it earlier. And if you want a reference, you've got to get data for that reference, but you've got to think about that objective and the benefits. What are you going to do with that monitoring data? But I think, certainly, it's the same in Australia as well. It's kind of consulting for impact assessment and stuff. There's usually monitoring involved, but it does nothing. They have to monitor for like a year or two, and then that's it. It's just it's a regulatory requirement often, but it does nothing. And I would say, don't do it. If that's all it does, there's no point in wasting that money.
But wouldn't it be possible to make it differently?
Yes, I think so. The better thing is to make it differently and make it meaningful.
Yes. And maybe it wouldn't be that expensive, because if you put that goal in the beginning, if you get the data, for an example, in the example you gave of development, building, you could take this data from the beginning, from before the development is done, and then during. That would be the idea. Actually, here in Brazil, that's the theoretical idea. But maybe to put that in practice wouldn't be that much expensive.
No.
And it would make more sense. I don't know.
I agree.
I don't know what we would have to do to implement that, actually. But
it's hard. And I've had lots of these discussions with state governments in Australia and stuff. But I think it's been more strategic, but I don't know what's going to make that happen.
I have a comment on that. So I did my master with road ecology, and I see that toll roads that are managed by private organizations, they have some rules and they have to monitor the road frequently. and that's a kind of monitoring going on. So there's a huge potential of using this kind of data for research. And I believe there are many other occasions in which monitoring is done, including what Clarice mentioned. So there's a lot of data being collected and organized. So maybe the effort should be in gathering them and working with these people that are out there doing this kind of work isolated. So I see a lot of potential on things going on. And the other thing is that the design of monitoring, for me, I see it as research. So the way you design it and you collect the data has to be well thought. And this can be combined with research. And there was something else, but as you know, I always forget something.
No, I agree. Yeah, sometimes there's lots of monitoring going on, and maybe the most cost-effective thing to do is not actually to go and collect new data, but actually put the institutions and frameworks in place to actually bring that data together to make it useful. Yeah.
Hi, I found highly interesting the social network structures analysis. I think I had seen some of that in my master's. An example in Colombia that they showed us. And I wanted to ask you is it possible to do this kind of analysis coupled with the depletion or not depletion of the resource, in this case the fisheries, and for example, more connected networks deplete less the artisanal fisheries than less connected, or compare a non-artisanal, like a multinational fisheries with a artisanal fishery or something like that.
Yeah, I think you could. So the artisanal fishery that we looked at in Kenya, I mean, it's actually not very well sustainably managed. And in our analysis, we just made some simplifications about the links, and we essentially assumed that there's influence links, so there's a spread of information, and then I guess using some theory from social science, using the idea that people who are connected behave similarly, so you can get this spread of some contagion of behaviour. But there could be collaborative links, which might be different. So I think you could. There's no reason why you couldn't, and you could scale that up or down. And I think that's one thing we're really interested in doing, is thinking in real networks, different networks. How does this play out? Yeah, I think you could. Yep.
Hi. I would like to know from your experience how often the decision to try to recover a species or to keep on monitoring the species is based on this framework or cost effectiveness you showed us, instead of some passionate decision, or just like, I like this species, this is charismatic, and I want to keep on monitoring this.
Yeah. As I said, I think this framework of formally ranking species is I guess I gave you a couple of examples there, one from New Zealand and one from New South Wales in Australia. There's maybe other examples around the world as well. I just know from those two case studies that they sort of used this ranking approach, but then did some adjustments based on value of the species or your charismatic species and so on. So you can weight species in different ways. So they did some of that. So the charismatic species or genetically unique species, they weighted higher. And I think in New South Wales, they had some species where they said, right, well, these have got to be funded because these are really important species. People care about them. So I think it's a mixture of formally using the formal approach and other things. And I think with all these decision frameworks, they're only a guide, and politics and economics and all sorts of other things come into play as well. So it's rare that they're just used at face value. Yeah. That's my experience. I don't know if anyone else has any experience of these formal frameworks, but yeah.
So maybe a last question. I was quite surprised to see this comparison that you have done with the koala conservation.
Yep.
So when we compare a decision with monitoring, so with information, without information, the additionality was really low.
Yep.
That was quite surprising for me.
Yeah.
And I don't know, we put a lot of money on long-term research. So we have in the United States the long-term ecological research, so what the LTR. We have something very similar here in Brazil, the PELT program. So we invest money on those long-term research program where monitoring is part of the research. So can you comment on the effectiveness of those long-term projects?
So the reason, so we looked at the koala example as a specific case where the objective of the monitoring is to improve management, and if monitoring doesn't change your management decision, it doesn't have any value, because if you're going to restore habitat before you collect any information, and you're pretty certain that even however much information you collect, it's still going to be habitat restoration that's going to be the best thing, don't bother monitoring. Spend that money on habitat restoration. So that's why the value of information is low in that case. It's just so obvious well, it's the other way around. But anyway, so it's the managing mortality directly is so obviously the best strategy. So in the long-term monitoring case, I think the objective is different. So in that case, it's more surveillance monitoring. So it's you're saying, well, we're going to just monitor these places, and we're going to learn some interesting stuff, and hopefully out of that, we're going to get some interesting insights that in the future is going to help us to manage things better. And I think, so that's that, if I had went through that list of monitoring objectives, that might be where that fits. And so the evaluation of that, the value of that might be different. And then you need to think about, well, what's the chance that I'm going to find out something amazing that's really going to revolutionize how we do conservation, for instance? And so Brendan Wintle, I think he has a paper in 2010 where he works out a framework to do that for surveillance monitoring, where you have these chance things that you might discover, but you don't know what. So maybe, if you think about it in that sense, maybe it has high value, but there's a big debate about whether we should do surveillance monitoring at all, or whether it should be targeted at particular questions. So, but I think you need to evaluate it in a different way. So I don't know whether that really answers the question, but
yeah. So thank you, Jonathan, and thank you also, Martine, and the whole audience for the presence here. And so now we have just a break. If you want to take some coffee, eat some biscuits, and make some personal questions for the speakers. So thank you again.